What comes to mind when you hear the phrase black hole? A demon-like space phenomenon that rips everything and anything in its path to shreds. Well, that's what we've been told, and to be honest, it's not far from the truth. However, black holes are not entirely demonic as we've been made to believe, and according to new discoveries, we might have them to thank for our existence. But how important are black holes to the formation of our universe? And what exactly do we owe them? A black hole is a region in space with a gravitational force so strong that nothing, including the particles of light, can escape it. Despite Albert Einstein predicting their existence many centuries ago, scientists initially weren't really sure if black holes exist or not. But thanks to the work of Sir Arthur Penrose, an Oxford professor, the existence of black holes was established mathematically and proved later on. Nowadays, astronomers are well informed that a supermassive black hole exists at the center of every galaxy, and that we're able to observe it using advanced scientific gadgets. Black holes are formed from stellar explosions that occur during the death of a star. During this process, called a supernova, the core of a massive star runs out of fuel and collapses. Consequently, a shock wave ensues, blowing up the outer layers of the star, which is how supernovas are formed. So technically, the heart of the star collapses, while the rest of it explodes outwards. This phenomenon spews millions of elements such as hydrogen, oxygen, nitrogen, and carbon. Gold and platinum were also among the heavier elements expelled by the explosion. Those elements then spread as a result of collisions between black holes and neutron stars. The air that humans breathe, the fuel of rockets that now help explore space, a man's wealth of gold, all of those originally came from a dead star that burst in outer space. Those substances generated by the birth and activities of black holes are responsible for the evolution of our planet. And perhaps without their being in the first place, neither Earth nor humans would have existed in this universe. A typical black hole must be at least 3 times the mass of the Sun and have an event horizon that measures a few miles across. However, a stellar mass black hole that weighs 10 times the size of our Sun can be formed within seconds after the collapse of a massive star. As for the more mysterious supermassive black holes at the center of every galaxy, scientists believe that they are formed over a longer period of time, perhaps up to 1 billion years. Whether for humans or objects, an encounter with a black hole is possibly the most dreadful experience in the entire universe. Anyone who gets trapped in the event horizon of a black hole will experience a perception of space and time that's very different from the one we experience here on Earth. As if that's not bad enough, as you plunge deeper, the immense gravity of the black hole will compress and stretch you in all directions like a cooked strand of spaghetti. This scary phenomenon is what scientists call spaghettification. But thankfully, no human has been subjected to this cruel punishment due to the enormous size of the universe. In other words, black holes are so far away from our solar system that their gravitational force is too weak to pull in any matter from our world. Expectedly, black holes will continue to grow bigger as they devour more matter. But the universe is not static either. According to scientists, the universe is constantly expanding, and if the current status quo is maintained, there will never be a black hole big enough to exert its gravitational force on objects and elements within our solar system. Some theorists have even discussed the chances of the Sun turning into a black hole. But in reality, that idea is dead on arrival because, for fact, our Sun is not massive enough to turn into a black hole. When the Sun eventually runs out of fuel, as every star does, it will become a sort of stellar remnant called a white dwarf. But supposing that the Sun somehow defies the norm and becomes a black hole with its current mass, it would still not affect the orbits of the planets around it, because its gravitational influence on the outer solar system would remain the same. Hence, the Earth would rotate safely around this hypothetical black hole without getting pulled in. However, the lack of sunlight would have highly negative impacts on Earth for sure. Over the years, black holes have earned a demonized reputation as one of the most devastating elements in space. But make no mistake, black holes have a good side to them as well. In fact, recent discoveries suggest that these terror elements may have been misunderstood. And it's hard to argue against these suggestions, because many things that have been reported about black holes are actually misconceptions. Perhaps the biggest of them all is that black holes are dark. On the contrary, the environment around black holes is actually bright. But how so? Well, as the core of a star collapses during stellar explosions, its rotational speed increases significantly, much like an ice skater who brings in his arms to generate a higher rotation rate. But in this case, the core of the star rotates even faster as it becomes smaller. Consequently, any matter that falls into a black hole is impacted by this intense rotational speed. As more matter shrinks into the hole, they leave behind a pile of junk at the edge of the hole, which creates a disk of violently spinning materials. The particles of this matter collide at great speed and generate massive heat through friction. Eventually, they become heated to millions of degrees until they begin to glow with intense brightness. This luminous beam of light is further amplified by the force of the black hole, which is millions of billions of light years away. And this is how astronomers detect black holes. Also, the enormous gravity of black holes distorts space itself, which makes it easy for scientists to spot the influence of the gravitational force of black holes on the celestial objects around them. Although not often publicized, black holes can get smaller as much as they increase in size. This was first explained by the Hawking radiation theory, put forward by the late Stephen Hawking. The phenomenon called Hawking radiation actually exists because vacuum of space is not entirely empty. Instead, they're filled by tons of particles that continually pop in and out of existence. In his work, Stephen Hawking proved that if two such particles are formed near a black hole, there's a good chance that one of them will be pulled into the black hole before it is destroyed, leaving its partner to escape into space. But mind you, the energy that powers this process is drawn from the black hole. This means the black hole slowly loses energy and, of course, mass. Based on the theory of Hawking radiation, all black holes will eventually evaporate. But it would certainly take some time. According to a scientific estimate, most of the black holes that exist now will require over 13 billion years to completely evaporate. Ironically, our world will experience drastic changes if all black holes in the universe evaporate. It doesn't really seem like it, but black holes are important to the existence of humans and the stability of Earth. For instance, during stellar explosions, millions of elements like hydrogen, oxygen, nitrogen, and carbon are ejected into the atmosphere. Similarly, heavy elements like gold and platinum are also discharged during this process. And as you know, all of these elements are important to the formation of the Earth and the activities of mankind. Also, the stellar explosion process that forms black holes is responsible for creating new stars. More importantly, black holes play a significant role in the evolution of galaxies. For one, the gravitational force of black holes helps pull the arms of galaxies, allowing them to run as required. In addition, the force of a black hole keeps the stars and other celestial materials within the solar system in their original positions. Without black holes, there will be nothing like gravitation, meaning there will be no basis for how a star can be formed. Lastly, the study of black holes has helped scientists unravel several mysteries within the universe, leading to outstanding technological advances that have directly or indirectly impacted the lives of humans all across the globe. Considering all of these factors, it wouldn't be wrong to suggest that we owe everything we have, including our existence, to black holes. And next time you touch your smartphone, bear in mind that the gold that's inside of it came from a cosmic explosion, when a beautiful beast called a black hole put an end to a life of a star. If you ever wondered how it happened, here we are to tell.